Liam wasn't looking for secrets. He was looking for a challenge worthy of his legendary reputation. A master restorer, specializing in hyper-luxury vehicles, he took on projects that official dealerships wouldn't touch. His latest acquisition was an insurer's nightmare, a custom-spec Ferrari Purosangue. Its matte gray body retrieved from a flooded subterranean garage beneath a Sardinian cliffside villa. The vehicle had been submerged for 6 months after a structural failure caused a massive intake of salt water. The Purosangue, the pinnacle of Ferrari's engineering, was now a $400,000 block of salt corrosion, mud, and complex, fried electronics. Liam knew the car's engine, the naturally aspirated V12, could be rebuilt, but the real threat was the corrosion clock ticking down on the aluminum chassis, the sensitive electrical harness, and the sophisticated suspension system. The immediate goal was triage. Back in his climate-controlled workshop, the first step was a meticulous, 9-day process of neutralizing the salt using specialized deionization baths, a process usually reserved for naval aircraft engines. Every bolt, every aluminum panel, and every section of the high-voltage harness had to be submerged, cleaned, and tested for residual chloride contamination. Liam's reputation hinged on achieving purity, returning the car to a zero-corrosion state. The most critical challenge was the active suspension system, FAS. The Purosangue relies on complex electronic actuators and fluid dynamics to manage its height and stability. The salt water had permeated the seals, seizing the electromechanical components. The entire FAS system was considered irreplaceable by the factory. Liam knew he had to rebuild it from the component level, sourcing specific, highly rare aerospace-grade seals and microprocessors. The restoration wasn't just fixing a car, it was reverse engineering a piece of future technology. Liam calculated that the restoration would require over 4,000 man-hours and push his skills to their absolute limit. The true value was not in the market price of the car, but in proving its engineering could survive the impossible. The heart of the beast, the naturally aspirated V12 engine, was next. Although sealed, salt water had invaded the intake and exhaust manifolds through microscopic cracks, settling deep within the engine block's aluminum cavities. The engine required a complete strip-down to bare metal. Every single piston, rod, bearing, and valve had to be individually x-rayed and tested for microfractures caused by the thermal shock of submersion. Liam discovered extensive pitting corrosion on the crankshaft and camshaft journals, damage that would ruin the engine's balance and power delivery. Rather than simply replacing the parts, which would cost over $200,000 and take months to source, Liam elected for a painstaking process of micro-welding and diamond dust polishing, restoring the journals to factory tolerances of less than 5 microns. This level of restorative detail required a custom-built, robotic polishing rig, a testament to Liam's dedication to preserving the original components. The most nightmarish challenge, however, was the wiring harness, the brain. The Purosangue contains over 5 miles of wiring, tied into hundreds of ECUs, sensors, and fiber optic lines. Salt water is a death sentence for modern electronics. The entire harness had to be replaced, but no single factory replacement existed. Liam had to hand-build a new harness from scratch, splicing over 6,000 individual connection points and soldering new gold-plated terminals onto every sensor. This was a process of automotive archaeology, requiring the meticulous documentation of the original corroded wiring loom before it was discarded. It was a race against time, as every day increased the risk of secondary corrosion spreading to the chassis. The entire team worked 12-hour shifts, wearing magnification goggles and fine motor gloves. The restoration became a crusade for engineering perfection, pushing Liam's small, dedicated team to the brink of collapse. The restoration wasn't about profit. It was about proving that the purity of Ferrari engineering could overcome the ultimate environmental enemy. Hold on tight. This Ferrari Purosangue is being rebuilt bolt by bolt, from a salt-eaten wreck to a hyper-SUV masterpiece. Liam is doing the impossible, hand-building a 5-mile wiring harness and micro-polishing the V12. You can't miss the rest of this engineering miracle. Hit that subscribe button right now and give this video a like. We're about to tackle the fast rebuild and the high-tech interior. Comment below. What's the most difficult component to restore on a modern Ferrari? Let's get back to the garage. With the engine restored and the harness rebuilt, the restoration moved to the chassis dynamics. The damaged active suspension system, FAS, was the key to the Purosangue's performance. Liam refused to fit standard components. He was determined to restore the original system. The core of the FAS, for complex electromechanical actuators, were disassembled. Salt crystals had formed in the fluid chambers, causing microscoring on the pistons and valves. Liam, collaborating with a specialized aerospace engineer, machined new, ceramic-coated pistons and seals, improving the corrosion resistance beyond the original factory spec. He spent weeks calibrating the fluid dynamics, ensuring the system could manage the car's weight transfer with the required precision. This part of the restoration alone cost over $150,000 in specialized labor and materials. The biggest hurdle remained the digital ghost. The Purosangue's ECUs were designed to talk to the original chassis components. The new, rebuilt FAS actuators had slightly different resistance signatures due to the custom ceramic components. The main vehicle management system, VMS, continually rejected the suspension, throwing critical error codes. The VMS was looking for the car's original digital signature, which had been fried by the salt water. Liam had to become a programmer. He spent days reverse engineering the VMS firmware, identifying the specific security protocols that managed the component authentication. He successfully injected a custom patch, the Purity Protocol, a unique digital signature that allowed the VMS to recognize and trust the rebuilt ceramic FAS components. This hack was performed purely for restoration purposes, ensuring the car would run without the factory refusing to service the custom rebuilt parts. Finally, the interior. The luxury leather, soaked in salt water, was irreparably warped and stained. Liam sourced the exact crema leather hides from Italy and, using the car's original digital seat templates, had the entire interior meticulously hand-stitched. The finishing touch was the restoration of the complex electrochromic glass roof, which required replacing the inner liquid crystal layer without damaging the laminated structure. The car was slowly returning to its original, breathtaking perfection. The moment of truth arrived, the final test drive. After thousands of hours of painstaking work, the Purosangue was lowered to the ground. Liam slotted the key into the dash. The V12 engine cranked and then roared to life, a deep, complex sound that filled the workshop. The VMS confirmed all systems were green. The car's recovery was deemed a miracle. The final cost of the restoration, including all specialized labor and materials, totaled $850,000, a figure that put Liam's finances under immense pressure, but proved the depth of his commitment. The restored Purosangue was presented to the insurance company. Its value was not just recovered, it was enhanced. The submerged Ferrari had become the restored Purity Protocol car, a testament to human engineering mastery over environmental catastrophe. The car was sold to a private collector at a premium, recognizing the unique story and the custom-engineered improvements to the suspension. The profit, after deducting the massive restoration expenses, was modest, but the reward was not financial. The real payoff was the global recognition of Liam's workshop. His reputation skyrocketed. Liam didn't just fix the car, he fixed a reputation for impossibility. The final legacy was the Purity Protocol itself. Liam used the custom firmware patch he created to launch a new, ethical consultancy dedicated to high-end component authentication, ensuring that rare and classic car parts could never be easily counterfeited. The Purosangue, once nearly lost to the sea, secured Liam's financial future by becoming the ultimate case study in engineering integrity. He kept one small memento, the original salt-pitted aluminum section of the main chassis, displayed in his new, expanded workshop. It was a permanent reminder that true perfection is only achieved after surviving the fiercest challenges. The story of the Purosangue proves that the greatest restoration challenges are not just about fixing metal. They are about reviving the integrity of the machine. For Liam, the master restorer, The prize wasn't the car's value, but the purity of its resurrection. If you want to uncover more stories of impossible restorations and automotive miracles, make sure you hit that subscribe button now and join us for the next great find.